All right, we are going to move on to the next section. Section 8.2, we are going to begin discussing properties of parallelograms. So these are all theorems, but I like to think of them as properties or rules or definitions, that type of thing. So what I'd like to do here, you can see we have 1, 2, 3, 4, 5 theorems / rules we will go through. And so let's draw a picture as we discuss them. All right, the first one. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So I'm going to add here, this is really the definition. So when you were thinking about how to define a parallelogram, it has the word parallel in it. So a parallelogram is a four-sided shape where both pairs of opposite sides are parallel. So we typically draw it like this. It looks kind of like a slanted rectangle. Of course, it doesn't have the 90 degrees. And so remember on parallel marks, the top and bottom will be parallel. So I'll put a single set of those arrowheads, or you can draw little triangles, and the left and the right. So I need more than one set because if I only put one, kind of like tick marks, it makes it look like it's parallel to the top, which clearly it's not. So if I were to be presented with this diagram, I would know it's a parallelogram because I see both pairs of opposite sides that are parallel. Okay, let's move on to the second theorem or rule. All right. If a quadrilateral is a parallelogram, then its opposite sides are congruent. All right, so we have a parallelogram here. If opposite sides are congruent, I'm going to have a tick mark, one single set of tick marks on opposite sides, and then a double set of tick marks on a second set of sides. Okay, so again, these visuals are really important so that you can determine what shape you're looking at. Okay, so first rule is opposite sides are parallel. Second rule, opposite sides are congruent. Okay, moving on down. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so sides and angles. So it looks like it says the same thing, but it's talking about angles. All right, let's draw parallelogram. And then angles, I'm going to put a single arc on a set of opposite angles, and then I'm going to put a double arc on a different set. So same with tick marks. Remember, these arcs tell us which angles are the same. Okay, opposite angles are congruent. All right, moving on down. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so consecutive, next to each other. Okay, and supplementary, add to 180. Okay, parallelogram. This one's a little harder to draw, so I'm just going to start with the parallelogram. And then I'm just going to put some numbers on here, okay? So let's call this a 40-degree angle. That means this one should be 140, and this one should be 140, okay? So here's your consecutive angles. Oops, let me fix that. And I was trying to write add to 180. Okay, same thing over here. So all the way around, you're going to have them add to 180. So of course this would also be a 40 up here at the top, upper right. So this also supports your opposite angles are congruent, but your consecutive angles are supplementary. All right. Okay. So far, we had opposite sides are congruent, or opposite sides are parallel, basic definition. Opposite sides are congruent. Opposite angles are congruent. And then our consecutive angles are supplementary. So those are the things I want you to say to yourself as you're solving problems that deal with parallelograms. Okay, our final rule here has to do with diagonals. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, let's draw a parallelogram. So you have to add diagonals, okay? So actually, let me switch colors here. So our diagonals, I don't know, let's do blue. Remember, they connect opposite vertices, so go ahead and draw them both. Okay, so there are my diagonals. Now, they bisect each other. So we have to recall what it means to bisect. So if something bisects, it splits it into 2 equal parts. 2 equal parts. Okay, so what that means is this piece of this diagonal is the same length as this piece. So I'm going to come through here and I'm going to put a single tick mark on those sections. Okay, maybe they're both 8. And then the other diagonal is also split in half, but very likely a different length. Okay, so we might have like 8 and 8. Maybe this one is 8 and this one is 8. Maybe this one is 5 and 5. So if I know the whole diagonal is 10, I can divide by 2 because I know that the diagonals are cutting each other in half. Okay? So that's the final rule on parallelograms. So we are going to take all those ideas, use them to help us set up equations and solve problems. All right, let's move on to example 1. Use the properties of parallelograms, find the value of x and y. All right, so here's what I notice. Opposite sides are parallel, so I know this is a parallelogram. Okay, I don't have to be told it's a parallelogram. So what I see here is, if I start with x, I know that my opposite sides are also congruent. So I can set 4x minus 1 equals to 15. Okay? Now, side lengths will be shown on the outside of the shape, right here, like it's shown. Angle measures will be shown on the inside in the angle measure. All right, so then let's just solve this equation. Let's add 1, to both sides. So when we divide by 4, I get 4 for x. Okay, I see that y is an angle. So I also know in a parallelogram the opposite angles are congruent. So I know that y is also 53 degrees. Now, if I was asked to explain my reasoning, I would just write down really what I highlighted back here. Like I would write down, for x, I would say opposite sides are congruent, and for y, I would just say opposite angles are congruent. Okay, so if you need to explain it, you can just quote those rules. Okay, I'd like you to do number 2. So pause the video and then come back when you have a solution. Okay, what I see on number 2 is that these are consecutive angles, and then they are, I'm supposed to say supplementary, a little bit sloppy. They are supplementary. So I can add them together, and I know it equals 180. All right, let's solve it out. So let's take away 42 from both sides, and I get 138, and then divide off 2, we get 69. Okay. Now, I could have also calculated that, let me change colors here, that if this was a 42-degree angle, this was a 138-degree angle, and so I could have said 2x is 138, but see how I calculated that in my equation above anyways? So that's another way to approach this problem. Okay, number 3. The diagonals of parallelogram VWXY intersect at point Z. Find the coordinates of point Z. So I want you to notice, like if you're trying to name a parallelogram, you can use that symbol. And then when you name any polygon, you want to name the points in an order so that when you look at the shape, it goes around the outside of the shape like this, and you can see it's constructing the shape. Okay, I don't want to name it like going across the shape itself. Okay, diagonals. So what I know about diagonals is they bisect each other. They cut each piece into equal parts. All right, so I know that these 2 pieces are equal and then those 2. But I need this coordinate right here. Now I can take a pretty good educated guess, but I need to exactly calculate it. All right, so if you think about, okay, think about a coordinate plane. If I know that on this segment, this point is exactly in the middle, then on a coordinate plane, this is the midpoint. So I can just calculate the midpoint between V and X using the midpoint formula. Okay, so let me just make a couple notes here. I'm going to say here Z is the midpoint. It's really the midpoint of either segment. Okay, and so we have a formula for that. So midpoint formula, I'm going to put M, actually, yeah, we'll do M for midpoint, is you're averaging your points. So I'm just going to, the midpoint formula is x1 plus x2 divided by 2, and then take the y's and average them. Y1 plus y2 divided by 2. So I can use V or X, it doesn't matter. I'm just going to use those two. So V is at 0, 0. X is at 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. Let me check that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yeah. All right, so to get Z, I'm going to do 0 plus 7, add the x's, add the y's. So 0 plus 7 is 7. 7 divided by 2, I can leave it as 7 halves, or I can go ahead and call it 3.5. And then 6 divided by 2 is, oh gosh, my screen keeps shaking, 3. So does that make sense? 1, 2, 3.5, 1, 2, 3. Yeah, so that looks reasonable. So you need to alter your thinking. When you're dealing with midpoint, you're in the middle if you're on a coordinate plane. So middle is midpoint. Okay, I want you to try to do as much of 4 as you can. I want to point a few things out to you. So 3M right here is along this segment. So 3M is this piece. 2N is over here. 2N is along QT. 15 is along TR. Okay, so when they're on the interior of the shape, they're going with an inside segment. Okay, 2x, you can see this is a degree. It's pointing to the whole angle R. No, I take that back. It is pointing, no, it's pointing to the whole thing. Sorry about that. So the reason that these arcs are here is because it's telling you it's pointing to the whole thing there. Same thing with 5 times x plus 1. It's pointing to this arc. Okay, so it's pointing at all of angle S. Okay, so that's a little bit confusing. So the reason these arcs are here is to show you it's the whole thing. All right, I want you to pause. I want you to notice it's a parallelogram because of this mark right here, and I want you to calculate A, B, C, and D. Okay, I need PR. I need the whole diagonal. And what I'm going to do here is notice this side is 15. So this one is also 15, and I can just add the two 15s together to get 30. Okay, I need just ST. So let's see. ST. Okay, it took me a moment here. 12N is right here along ST. 2N is along QT. So I know that these diagonals are equal. So I can do 12 minus n. I can set it equal to 2n because they are equal to each other. Okay, so that's the setup on that one. Now solve. Add n over to both sides. And then I get 4 for n. But I need ST. So if I plug 4 in right here, 12 minus 4 is going to give me 8. Okay, SRQ. Let me change colors here. SRQ. So SRQ is all of this angle right here. So I can work with its relationship with angle S over here, and those two angles are supplementary. So I can take those two expressions because it's pointing at the whole angle, and I can not set them equal to each other. They are supplementary. So I'm going to add them together and set them equal to 180. So that would give me 5x plus 5 plus 2x. So 5x and 2x is 7x. I'm also going to take away 5 in this step, so I get 175. And then divide by 7, so I get 25. But I need the angle measure. So I'm going to come back over here. SRQ is this one, which is attached to 2x. So if I go ahead and substitute that in, I would get 50 degrees. Okay, PRQ, PQR, excuse me, P over to Q down to R. Okay, so PQR is this one, so angle Q. Now, I know that angle Q and angle R are supplementary. So if I know here that angle R is 50, I can just do the supplement, 180 minus 50, and that will give me 130. So that would be the measure of PQR. Okay, well that wraps up parallelograms. So as you work through these, I encourage you to say to yourself these rules. Okay, so there's 5 rules for if you have a parallelogram, these items are true. Okay, that wraps up.